Byron Wallace is speaking to us next. He's an assistant professor at Northeastern University, and where he directs the BS in data science. And he also has an appointment at Brown University at the Center for Evidence Synthesis. He works as well in the sphere of machine learning and natural language processing, making reviews more efficient, or certain tasks of reviews more efficient. And he's going to talk to us today about risk of bias assessment. Thanks, Byron.
So thanks very much for having me. So far, it's been really a fantastic panel. So I'm happy to be involved. So what I'm going to be talking about today is mostly stuff about trying to semi-automate risk of bias assessment, but I'll sort of talk a little bit more broadly about some of the work that we've been doing as well. And so, while I'm the person that's going to be presenting this, all of the stuff that I'll be talking about today is really a collaborative effort that's co-led by Ian Marshall, who is also here with us, and he'll be on the panel later. It's also collaborative with a whole bunch of other great people, but I think I'll call out Ian in particular. Okay, so a lot of times when I give these this sort of talk or some variant of this talk, I'm speaking to computer scientists, and I have to give a sort of spiel about the rate at which the evidence base is expanding. But I think for this audience, that's already well appreciated, and I think both James and Adam did a nice job of talking about some of the obstacles we face. So I'll sort of skip that, but this is just a plot that's showing basically the number of just reports of randomized control trials that are being kind of published year over year. And so, the way that I got involved with this as a computer scientist is I was collaborating with Tom a bit. Tom's also on the panel, and so this is Tom, for those of you that don't know him. And he was doing things like wading through sort of these massive piles of unstructured evidence, this kind of literature. And as a computer scientist that was interested in natural language processing, this seemed completely insane to me. And of course, it didn't make Tom happy. I dredged up this old staged photo of Tom being kind of unhappy because of all the kind of evidence that he had to wade through. And so a lot of sort of since then, which was a long time ago now, maybe over 10 years, a lot of my time has been thinking about how to make Tom's life, I guess, more pleasant so that he can do kind of thoughtful appraisal of the evidence, and we can try to automate some of the boring stuff, or at least semi-automate it. Okay, so with that kind of grand aim in mind of I guess, making Tom happier, Ian and I have been working over a number of years now on this project that we call Robot Reviewer. And the idea with Robot Reviewer is it can ingest articles, either full text articles as PDFs. We also have variants of the models that will consume just titles and abstracts, and it will kind of perform or apply a bunch of machine learning models that we've trained up. And these models will do various things. They'll, for example, extract Pico elements like James described. And we also have models that try to extract kind of the main study findings and infer sort of what the directionality that's being reported is. And also, most relevant to today, try to infer or try to sort of automatically construct a risk of bias table. So it's probably easiest to just show a now slightly outdated demo. So here the idea is these are a bunch of PDFs that are all describing trials on the same clinical topic. You sort of upload them into the system. It does its thing in the background and sort of generates, for example, a risk of bias table in the typical sense. And it will also, as I said, kind of extract the main Pico element, and you can kind of click through and navigate to from where in the underlying PDF these were extracted. So that's the idea behind Robot Reviewer, and I'll be talking today in a bit of detail about the risk of bias component, right? So I imagine that folks on this call are largely familiar with the idea behind risk of bias. So this is a formal tool for appraising, I guess, the reliability of the results reported in clinical trials. And we're following the Cochrane risk of bias tool. And very concretely, we're considering sort of 4 core criteria, right? This is random sequence generation, allocation concealment, blinding of participants and personnel, and blinding of outcomes assessment. So the idea is that for each of these domains, we're going to want to assess a trial on the basis of a report describing its conduct and results, whether it's at low or high / unknown risk of bias. So we group those latter 2 categories together sort of for convenience. And I guess importantly, we also want to provide support in the form of a snippet extracted from the underlying article to present, let's say, to the user, right? Because we really have in mind semi-automation. And the reason that we want to do this, the reason that we might want to kind of semi-automate this process of risk of bias assessment is because it's quite time consuming, right? So there was an estimate from a while ago now that it takes something like 30 minutes per paper just to do sort of this one task, right? So that's the motivation. I guess from the natural language processing or sort of machine learning perspective, you can view this as a particular type of supervised learning where we aren't just trying to do only classification, we also want to be able to provide what you might call rationales or sort of snippets of evidence that support those classifications. And so this kind of motivates the approach that we've adopted here, right? So a number of years ago now, actually this was 4 years ago, in sort of the timeline of modern machine learning and natural language processing is like 3 or 4 decades, I think. But nonetheless, the model that we currently have in Robot Reviewer is still using these kind of rationale augmented convolutional neural networks that we've introduced. And the idea here, I'm not going to go into the nitty gritty too much given the audience, but the general idea is we're going to take a full text article describing a trial. We're going to sentence segment it, so break it into the constituent sentences. Run those sentences through some sort of a neural network that's going to give us a representation of those sentences. Nowadays, you would probably drop in some sort of a BERT model or other Muppet, for those of you that are familiar with these sorts of things. And then you're going to take those sentence vectors, and here's the kind of different part. Each sentence is associated with a label that says whether it does or does not provide a rationale or evidence for risk of bias assessment with respect to a particular domain. For example, there will be like one sentence somewhere in the full text article that's perhaps describing how the random sequence generation was done. And we want to be able to kind of recognize that sentence. And once we've recognized that sentence, we can pass that forward to a subsequent model that's going to be responsible for the classification, which says this is at low risk of bias, let's say, for random sequence generation, just as an example, right? And that's the kind of top level model. Okay, so that's the kind of general idea. And this thing works pretty well. Again, I think the underlying methods perhaps aren't the major issue at stake in this presentation. But what I would say is exploiting these kind of rationales, both at training time and at testing time, improves the model in 2 ways. It improves the predictive performance. So we can see that the thing that I just described, which we call the rationale augmented convolutional neural network, or CNN, that's the like sort of salmon colored thing. And this outperforms for the 4 domains a bunch of different sort of baseline variants that we compared to. I suspect that we could gain a little bit more ground if we sort of updated to even more modern methods. And it's something that Ian and I have on our agenda, but just sort of haven't gotten around to retraining those things yet. So I would push back just a bit on James's earlier point, although I do largely agree that oftentimes you get a whole lot of mileage out of sort of very simple logistic regression. I agree with that position. But at the same time, I do think that the advances in kind of modern NLP are, it's good to be cynical of them, but I do think that they are sort of fast enough right now that we're starting to see gains that actually can be imported into this domain. And maybe we can talk about that a little bit more during the discussion. So in terms of, so that's sort of the modeling side at a relatively high level. In terms of the evaluation in practice, there's been a couple of interesting efforts independent of us to assess the risk of bias assessment that's in Robot Reviewer. So there's been a couple of nice studies that have been done by other folks in other groups. And reading these, one thing that we always try to emphasize when we talk to people is really the semi-automation aspect. And again, I think that gets back to James's point about kind of human in the loop stuff. In particular, we really don't have in mind kind of replacing the humans completely. We really would like to augment them. And with this in mind, we actually did our own trial of the risk of bias assessment component of Robot Reviewer. And in particular, what we've done is we sort of recruited 41 participants. Probably some of you on this call helped out, so thank you if that's true. And each of them performed risk of bias assessment for 4 randomized control trial articles. all of them used our interface, but we randomized it so that for 2 of the articles that they were randomly assigned from a larger pool of articles, they received a pre-populated Cochrane risk of bias sort of form, if you will. And in the other 2 cases, they just did it fully manually. Right, so here's what this kind of looks like schematically. We have a whole bunch of pool articles. These are all randomized control trial reports. And we randomly sample 4 articles per participant. And we basically use semi-automation in 2 of those cases in a random order and had them do the risk of bias assessment fully manually in the other 2. So they always saw this interface. This is always what the interface kind of looked like. And that bit on the right there, that's where they sort of performed or entered the assessments, right? And the only difference between the case where they were getting the semi-automation and where they weren't is that in the case where they were getting the semi-automation, this is pre-populated. And they could override that, right? So basically, if it said, oh, I think this is low risk of bias for random sequence generation, and here's the rationale that was used by the model, then they can kind of overwrite that if they think it's incorrect. So that's the idea. So I guess the first question is, does it actually speed the process up? And the answer is yes, by about a quarter. But it's not hugely significant in terms of labor savings, but a quarter is not nothing, especially when you're talking 30 minutes per article. And perhaps more importantly, I guess 2 things. One is that the users seem to like working with the system as per the usability survey that we did. And also, like, if you look at the quality of the rationales as kind of evaluated by looking at how many times people removed, like basically overrode the rationales that were provided by the model, they seem to be quite good. What this is showing on the left-hand side there is it's saying that most of the time people didn't delete any of the rationales that were extracted automatically. And that can be kind of taken as a measure, I guess, of the precision of the rationales. And then you can kind of look on the other hand, on the right-hand side, and see how many times people actually added rationales manually. So basically, these were cases where maybe the model missed something that would have kind of explained whether or not the random sequence generation, let's say, was done properly or improperly. And that was also quite rare. So most of the time they did not do that. And that's kind of a proxy for recall, I guess. And as I kind of alluded to, we also did this usability survey. And broadly speaking, I won't go over this in detail, but broadly speaking, the tool was kind of well received and people kind of subjectively found it useful. So we were pretty optimistic about the results of this trial for expediting risk of bias assessment. So that's kind of like the core envisioned use that we had for risk of bias assessment when we first started working on this problem. I think more recently, we've been thinking about other ways of using kind of estimates of risks of bias that are automatically induced. So as one instance of this, the TRIP database includes robot reviewer estimates for risk of bias concerning each of those domains. And I think the idea here is basically to prioritize retrieval of seemingly high quality evidence. And we do a similar thing in this trial streamer prototype that James alluded to as well in his talk. So in particular, we use it for ranking. And just as a quick overview, or I guess a refresher of what trial streamer is all about, what we're trying to do here is we're monitoring PubMed mainly. And every sort of night, we run a model that we've validated in prior work to identify newly published reports of randomized control trials in humans. And we take the articles that are identified as such, and we push them through the suite of models that are sort of in Robot Reviewer. And these models do things like extract the sample sizes, the PICO elements, the risks of bias, as I mentioned, and also the main findings and some other stuff, and push those all into a structured database, which we make publicly available. So you can grab that. It's updated every night. We also make available a prototype interface for kind of interacting with this database, right? And here's what that looks like. And so I mentioned sort of using the risk of bias, and the way that we do that, or one of the ways that we do that, is if you enter a search, and you can do faceted search, so by population, intervention, and outcome. So if you enter a search, let's say for COVID-19 and remdesivir as an intervention of interest, we'll retrieve trials, and you'll notice that we kind of retrieve the trials that are largest and highest quality first. And for largest, we use the extracted sample size, which our models do. And for a proxy of quality, we use the probability that a study is at low risk of bias as per our model, right? So that's kind of how we use that in this case. And I wanted to mention one last thing, which is much more, I think, on the experimental side, where we also use risk of bias predictions. And this concerns trying to actually go one step further and actually generate a narrative synthesis of the evidence, right? So basically the task from an NLP perspective is you're given a set of titles and abstracts corresponding to randomized control trials that might be all on the same clinical topic. And what you want to do is output something that looks like the author's conclusions subsection of a Cochrane review, right? So we've actually trained up models to do this. So here's, again, very experimental, but this is something that we're sort of investigating. So here is output if you basically search for migraine as your population, triptans as your interventions. And what we do is we shove the top K retrieved studies in TrialStreamer through our summarization model, and it outputs a natural language summary of the evidence. And in this case, I think it's actually reasonably accurate. I'm not a real doctor, so I can't say that with confidence. And you could do something similar, for example, with a timely example like COVID-19 and hydroxychloroquine, and it'll tell you that there's not sufficient evidence and so forth. So this is something that we've been looking at. And the way that we use risk of bias assessment is basically in prioritizing what pieces of the input can be consumed by the model. So obviously I don't have time to go into the models in much detail, but we're using this thing called BART, which is an encoder-decoder model that uses these deep kind of transformers, which are big neural networks that we all kind of know and love in NLP now. And the idea is that the encoder consumes the titles and abstracts of all of the constituent articles that correspond to a review, and the decoder is going to conditionally produce a summary on the basis of these. And the thing is that just logistically, because of like memory constraints, you have a budget of the number of words that you can feed into this big model. And in particular, it happens at the moment to be something like 1024. So you get about 1,000 words that you can fit into your encoder to produce a summary. And so you probably won't be able to fit all of the relevant titles and abstracts into that budget, that token budget. And so one of the things that we do is we try to prioritize the inputs by sort of prioritizing large and high quality, in other words, low risk of bias or predicted to be low risk of bias studies. And this turns out by doing this and sort of prioritizing the inclusion of these studies in the token budget, it tends to increase performance a bit. And in particular, we assess this by, so one of the kind of interesting things here is that if you look at these summaries, they're pretty convincing. But if you actually read them, you'll find that they're often not quite accurate. And so this is not something that we know how to automatically evaluate very accurately at the moment. So we again involved humans, and we hired up some folks that have medical training to assess the factuality of the generated summaries. And here's like basically what the interface looks like for doing that. And what we found is that all of the summaries that were generated automatically were deemed, these are different strategies. I won't get into it, but these are different kind of variants of the model. And one of them is this sorting strategy. And all of them seemed to yield summaries that were convincing. So they seemed relevant and highly fluent. So they read like real evidence synopses, but the factuality was deemed to be quite poor across the board. On the other hand, doing the sorting thing, prioritizing inclusion of high quality studies, does seem to increase that a bit. So there's some promise there, but there's still a long way to go before this kind of thing can be practically useful. Okay, so I think I'm on time. So I will stop it there, and hopefully we can have some interesting discussion at the end of this. So thanks.